Why he is not using the UET official account? So he needs to use the official account. Anyways, okay, Hazrat Bilal. So we studied about anyone else. Syed Wakar Yunus. What was our discussion point in our previous class and discussion topic which we discussed?
So we studied about triaxial test sample preparation, different processes that involve in the sample preparation, about stresses, development of stresses, pore pressures.
Okay. You all students are connecting from your official UET Peshawar email address, right?
Yes, sir.
Yes, sir.
Everyone. Okay. Thank you. Okay, Wahidullah. So, what we studied in our previous class?
Sir, sample preparation, saturation, consolidation, or CDCU, consolidated, drained, consolidated, undrained test in triaxial test.
Okay.
Conditions in triaxial test. Sir, और इसके अलावा stress path.
Okay, good. Are you sure that we studied consolidated drained and consolidated undrained test? I think so. We left this topic for today's class, I guess.
No, sir. Yes, sir. Bilkul. We haven't studied that. You have just
Yeah, because we
light
went
on
for
it.
just only unconsolidated,
Undrained.
undrained test and unconfined compression test.
Yes, sir.
Sumer. Okay, so tell us about the unconsolidated undrained test. What is unconsolidated undrained test? How we
सर
perform?
कंसोलिडेट में जिसमें हमारे
Yes, please, briefly.
सर कंसोलिडेशन में सर जिसमें हम मतलब हमारे पास जो ड्रेनेज है वो हम उसको अलाउ करते हैं और अनकंसोलिडेटेड ड्रेन में हम ड्रेनेज अलाउ नहीं करते.
Okay, Tehreem, please tell us about the unconfined compression test. How we perform unconfined compression test. Tehreem, can you hear us? Please. Why we perform unconfined compressive test? Tehreem Javed. Why we perform and how we perform unconfined compressive test? Okay, Hazrat Bilal, can you please help
Sorry,
Yes,
us
sir.
here?
with my mic.
Thank you very much, Tehreem. Hazrat Bilal, please, can you continue with the unconfined compressive test?
अनकन्फर्म कंप्रेशन टेस्ट में हम shear strain पैरामीटर्स फाइंड करते हैं, लेकिन ये मेनली कोहेसिव सॉइल के लिए होता है. ये एक यूनी एक्सियल टेस्ट है जिसमें सिर्फ एक ही डायरेक्शन पर हम लोड अप्लाई करते हैं क्लेई सॉइल के लिए. और जिसकी वजह से हमें वो लोड और सेटलमेंट का अंदाजा होता है, उससे हम एरिया फाइंड करते हैं और फिर उसी वजह से हम फिर कोहेजन फाइंड कर सकते हैं किसी भी क्ले सॉइल के लिए।
Okay, thank you very much. So in today's class, we are going to study about the shear strength of the soils, and also we will extend our concepts and understanding related to the triaxial testing. Now in previous lecture, we find out that we can like unconsolidated undrained test and unconfined compression or compressive test, and from these two tests we will find out the undrained shear strength of the soil. Now, as we know that in the field there are conditions which are undrained, and there are also conditions where we will experience drainage. Now, for undrained condition or the short-term condition, or we can also say the total stress analysis condition, these three names are used interchangeably for each other. Now, in case of drained analysis or long-term analysis, or we can say effective stress analysis, we need to find out the effective strength parameters, for example, C prime and Phi prime. Now, in order to obtain these effective shear strength parameters, we need to perform the consolidated undrained test and consolidated drained test. Now, in order to perform the consolidated drained test, first stage is to consolidate the specimen to the desired effective stress level, like for sigma 3, and pressurizing the water in the cell and allowing the soil sample to drain until the excess pore water pressure dissipates, which means that UE will be equal to 0. Now, the pressure, which is sigma 3, is kept constant, and the additional axial loads or displacements, for example, sigma D, is applied until the sample fails. Now, we can control the strain rate, and we need to use in such a way, or we need to shear the specimen in such a way that the excess pore water pressure is dissipated. Now, you need to perform at least 3 tests so that you can draw the Mohr circles, and then you can find out the best fit line to find the cohesion and friction angle, or the effective strength parameters. Now, in isotropic consolidation stage, so we all know that we apply sigma 3 and delta U is equal to 0. Now, if you want to write that in other way, so we can simply write down that delta sigma P prime, or the mean effective stress, or the change in the mean effective stress, will be equal to delta sigma 1 plus delta sigma 2 plus delta sigma 3. Now, if we already know that delta sigma 1 is equal to delta sigma 2 and delta sigma 3 in case of the consolidation stage, however, this can be also simplified and written as in this form, that deviator stress, which is delta sigma 1 minus delta sigma 3, is equal to 0 because there is no sigma d is applied in the stage 1 case. So we can also write a ratio which will give us the stress path, and delta q divided by delta p, which is the deviator stress divided by the mean effective stress changes, is equal to 0, and that is related to the stage 1, which is the consolidation stage. Similarly, now in shearing stage, delta sigma 1, or if you are dealing with the delta sigma 1 prime, which is effective stress, it should be greater than 0 because sigma d is applied now, and that sigma d will increase the sigma 1, which is the major principal stress. Now the change in sigma 3, or the confining stress, will be equal to 0 because we are applying the constant sigma 3, or the confining pressure. For example, sigma 3 is equal to 100 kilopascal, or sigma 3 is equal to 200 kilopascal. So we try to keep that confining pressure constant, and delta U is equal to 0. Why? Because this is the drained condition, and as we mentioned earlier on, that we are also
सर वली को ज्वाइन करने में मसला है सर, उससे सर आप ग्रुप में सर लिंक शेयर करें प्लीज।
वली को बोल दें कि ऑफिशियल ईमेल आईडी से प्लीज काइंडली जो है ना वो लॉगिन हो जाए,
ठीक है
या
सर।
आपके साथ बैठ जाए प्लीज, ठीक है ना, या आपके साथ बैठ जाए। आप किधर बैठे हुए हैं?
सर शहदुल्ला यूनिवर्सिटी में शहदुल्ला के साथ बैठ जाएगा।
हाँ, तो आप उसको बोलें कि शाहिदुल्लाह के साथ जो है ना, शाहिद अली खान के साथ जो है ना वो बैठ जाएं प्लीज, या जो है ना आप इस तरह कर लें कि ऑफिशियल जो ईमेल आईडी है उससे लॉगिन करें अपनी, जो उसकी यूटी पेशावर की है। और रिफत अल खान, आपकी जो असाइनमेंट है आपने सबमिट की नहीं है, तो जिनकी असाइनमेंट सबमिटेड नहीं है तो प्लीज काइंडली वो सबमिट कर लें, ठीक है। रिफतुल्लाह खान,
ओके सर, ओके सर।
2 बजे डेडलाइन थी, प्लीज।
ठीक है, मैं सर सबमिट करूंगा।
Okay, thank you. So, yeah, please listen very carefully, and I'm going to note down your attendance as well. Those who are not absent, Shahid is now present. Maz is also present. Okay, Rifat is also present. Okay, so now, as it's drained condition, we are discussing the consolidated drained test, and in consolidated drained test, we apply the strain rate very slow. So therefore, we will have delta U is equal to 0, and the change in delta sigma 3 will be equal to 0. Therefore, we can write the mean effective stress equation, delta P is equal to delta sigma prime 3. Okay, and delta Q will be equal to the change in the major principal stress because sigma D will be applied. Now, if you want to find out the ratio between delta Q and delta P, or in other way, we can also write delta Q is equal to 3 into delta P, or Q is equal to 3P, which will help us in the stress path as well. So the basic concept which is shared in here, that in stage 1, in schematic form, you can see that delta U is equal to 0, and you apply the confining stress, and the confining stress means that the all around pressure because here we are having water, so the all around pressure which is exerted onto the sample will be equal to sigma 3. And now you can say that delta sigma 1, delta sigma 3, or delta sigma 1 prime equal to delta sigma prime 3. When we move towards the stage 2, stage 2 U is 0 because it's drained, and delta sigma 3 means change in confining pressure or cell pressure is equal to 0 now, and sigma 3 is also equal to sigma 3 prime. Now sigma 1 prime, which is the major principal stress, is equal to sigma 3 prime, and if you remember, this sigma 3 prime was present here, and that is due to the consolidation stage. Once this is due to the consolidation stage, now the force per unit area as the actuator is present here is moving with a certain strain rate in percentage, or we can say percent per minute or per hour, something like that. So that should be the unit. So the force per unit area will give us the sigma D, the deviator stress. Deviator stress. Now we can also represent the same discussion which we started with the explanation and then the schematic diagram there. So we can also explain that in terms of the figures. For example, that this is the stage 1, which is the consolidation, which means that Q is 0, or I would say sigma D is 0 in this case, and we are increasing sigma 3, and that sigma 3 is related to the mean effective stress, which is sigma 1 plus sigma 2 plus sigma 3 divided by 3. And if you are talking about the effective stresses, so we can also write that as sigma 1 prime, sigma 2 prime plus sigma 3 prime. So this is the prime divided by 3. So in consolidation stage, the stress path will lie on the isotropic compression behavior and isotropic compression line. And then as we derived the equation that Q by P is equal to 3, or Q is equal to 3P, which means that one horizontal increase in P will cause 3 kilopascal, or 1 kilopascal increase in P, which is the confining pressure, will cause 3 kilopascal of the deviator stress deviator stress or the slope is equal to 3. So now in case of consolidated drained triaxial test, the effective stress path and the total stress path are same, having the slope of 1:3. It's a very important point which we are going to discuss in the stress path lectures as well. In other way, we can say that, for example, this would be sample preparation stage. So the time is being paused and u is equal to 0 here. And if you draw the pore water pressure versus time behavior, so when the time is passing by, when you're preparing the specimen, there won't be an increase of the pore water pressure here. But when you apply the consolidation or the confining pressure, immediately the pore water pressure will shoot up and you will get the positive pore water pressure. Now in consolidation stage, which is a drained stage, again the excess pore water pressure will be equal to 0. And then we will do the shearing stage, and then the pore water pressure, because it's drained test, now again the pore water pressure is 0 based upon the slow shearing and also the open valve condition. Okay, the test is performed so that there is no generation of excess pore water pressure. Please kindly use your official email. Okay, I'm requesting last time, please kindly use official UET email. Thank you.
सर काइंडली आप ये जो हमारे पास वहाँ पे सर लिंक शेयर होता है सर, वो आपने हाइड किया हुआ है तो स्टूडेंट्स वहाँ से नहीं देख पा रहे हैं, और जब भी वो लिंक पे क्लिक करते हैं जो आप ईमेल पे सेंड करते हैं, तो बाज़ दफ़ा उनका ऑफिशियल ईमेल जो है ओपन नहीं होता, तो फिर वहाँ से वो इंटर नहीं हो सकते, तो फिर उनको मसले आते हैं सर। तो काइंडली अगर आप वहाँ पे हमें विजिबल किया करें तो स्टूडेंट्स गूगल क्लासरूम से डायरेक्ट जो है इन हो सकते हैं।
तो लिंक और कोड तो मैंने शेयर किया हुआ है और उसको मैं विजिबल भी कर लेता हूं। अभी विजिबल भी हो गया है, अभी चेक करें प्लीज।
विजिबल हो गया सर, विजिबल
अभी ठीक है सर।
वली आप शायद के साथ बैठे हुए हैं कि नहीं?
बस मैं जनाब खुद ज्वाइन किया सर।
आप खुद नहीं, ये शायद की आवाज है या वली की आवाज है? ओके, वली ने कर लिया है, ठीक है। वली जो है ना, वो वली को मैं प्रेजेंट लगा लेता हूँ। वली आगे प्रेजेंट है और बाकी
उसको सर मैंने मोबाइल दिया है तो इस वजह से उसने मेरी आईडी मोबाइल से किया है और मैंने लैपटॉप से ज्वाइन किया हुआ।
ओके, नहीं वली तो यहाँ पे मुझे जो है ना वो दिखा रहे हैं।
अभी लिंक आपने शेयर किया तो मैंने अभी ज्वाइन किया ना, पहले शायद अली के मोबाइल से देख रहा था सर।
अच्छा ठीक है, ठीक है, चलिए। प्लीज काइंडली कोशिश करें कि आप एक दूसरे को जो ईमेल आईडी है वो ना दें और अपनी ही ईमेल आईडी से लॉगिन हुआ करें ताकि आपकी अटेंडेंस लग सके। डीन साहब और चेयरमैन साहब की स्ट्रिक्ट इंस्ट्रक्शंस हैं कि जो आपकी अटेंडेंस है उसको उनके साथ जो है ना वो कम्युनिकेट किया जाए और ये क्लास वैसे भी रिकॉर्ड हो रही होती है, तो इसको भी चेक किया जाता है कि मतलब इसमें कितने स्टूडेंट्स प्रेजेंट थे या कितने टाइम तक जो है ना वो प्रेजेंट थे। तो ये सारा डाटा जो है ना ये कोऑर्डिनेटर साहब के साथ आता है और पोस्ट ग्रेजुएट कोऑर्डिनेटर के साथ भी। तो मेरी रिक्वेस्ट ये सारी स्टूडेंट्स से यही होगी कि आप अपने ईमेल एड्रेस से लॉगिन हुआ करें ताकि आपकी अटेंडेंस जो है ना वो रिकॉर्डिंग में ऑटोमेटिकली आ सके। अगर आप शायद की ईमेल से 2 दफा जो है ना वो कनेक्ट होते हैं तो उसकी वजह से हो सकता है कि क्योंकि आपकी ईमेल आईडी से तो आप कनेक्ट हुए नहीं है, तो आपकी अटेंडेंस अनऑफिशियली जो है ना वो फिर अनफॉर्चुनेटली वो फिर नहीं लग पाएगी। ओके, प्लीज काइंडली कोशिश करें कि नेक्स्ट टाइम जो है ना जब मैं आपके साथ लिंक और कोड शेयर कर दूं तो लिंक और कोड के थ्रू जो है ना वो करें। जरूरी नहीं है क्योंकि विजिबल के में कुछ ना कुछ मसले मसाइल आते हैं कि हर बंदा जो है ना वो कनेक्ट हो पाता है, तो कुछ इस तरह इशू मेरे ख्याल में मौजूद है कि आउटसाइड जो डोमेन है उससे भी जो है ना वो कनेक्ट हो पाते हैं, समथिंग लाइक दैट। तो कोशिश करें कि क्योंकि अंडरग्रेड के साथ मैं जब शेयर करता हूँ तो उनको कोई इशू नहीं होता, मैं सिर्फ लिंक शेयर करता हूँ, कोड शेयर करता हूँ और तकरीबन 30-40 बंदा जो है ना वो 2 मिनट में कनेक्ट हो पाता है। तो देयर शुडंट बी एनी इशू फ्रॉम योर साइड एज वेल। थैंक यू वेरी मच। अच्छा, अभी आपने कनेक्ट कर दिया, अभी मैं हाइड कर सकता हूँ उसको, आई थिंक सो कि मैं उसको जो है ना हाइड कर लेता हूँ आपने जब कनेक्ट कर लिया है तो। ओके, okay, the illustration regarding the same phenomena of the sigma 3 application during the consolidation stage, application of the deviator stress during the shearing stage, and the major principal stress increase due to the sigma d is also presented in this figure. Now, if we want to find out the volumetric strain, so we can find out with the change in volume, and that you can obtain from the back pressure pump or the volume controller. Okay, an original volume V0 can be obtained from the height, depth, the diameter of the specimen, and epsilon 1 is the axial strain, and epsilon 3 you can say these are the radial strains, which are also can be obtained from the change in the volume. Similarly, the radial strains can be obtained from this equation, half of the volumetric strain and the axial strain. And if you want to find out the maximum shear strain, so those can be found out from the axial and radial strain. Equations you can note down, it will help us in solving the examples and problems when we move towards the numericals. Okay, now since the consolidated drain test is in a drained test, a single test can take several days, and if the hydraulic conductivity of the soil is low, you need to take into consideration the amount of time which this test is going to take, because we need to run at least 3 tests to get the shear strength parameters. So it's better to find out the hydraulic conductivity before, and in order to run the consolidated drained test. It will give you an idea that how long it's going to take. We can also find out the elastic moduli, but that is not the focus of our this chapter. So we will deal on the stiffness parameters in a separate lecture, because these are also very important in constitutive models. But for the time being, we can clearly see that if you want to find out the initial or the tangent shear modular, the modulus, if you want to find out the secant Young modulus, so we can easily find out using the deviator stress and the strain. Okay, at particular strain level, we can find out the Young's modulus or the modulus for that particular stress or the strain range. Sand behavior and dense sand behavior, which we discussed in our first lecture, and if we perform 3 tests, then we can get the peak friction angle and the critical state friction angle as well. How we perform the consolidated drained test? First, we need the porous stones, or some people call those as porous discs as well. We need those drainage tubes because the pressure will be generated or the sample will be flushed through the drainage tubes. Now, as we already discussed, the cell is filled with water and it's pressurized. Mechanism can be different using balloon, using water, or using the pumps there. Now, during the shearing stage, the drainage path is left open. We say the valve is open, or in various instruments, apparatuses, the back volume or the back pressure volume will increase because the water from the sample will go out. So here, if we assume the sample and if we are consolidating it, so the pore water will go into that pump, and that pump, for example, is filled till here. Now if the pore water is coming into this pump, so what would happen? This pump was empty till here. Now it will be, no, sorry, it was filled till here. Now the pump will move till this point, and now the pump would be filled till this much volume. Okay, so the volume of the water will increase, and that's how the GDS back pressure controller monitor or record the volumetric changes. Samples are sheared very slowly in order to avoid the generation of excess pore water pressure, which can definitely change the readings and the shear strength of the soil. Now, step by step method can also be, the procedure can be also explained here. So first, if we start with the sample preparation, which we will discuss today because that was part of our assignment as well. So we will have a short discussion on it. So how and what are the different types of sample preparation we are going to perform if we are solving, if we are running tests for a term project, or if we are running tests for our own research, or if we are running the test or we are conducting the test for solving the assignments as well. So first of all, we do sample preparation, and then we do the saturation stage. And for saturation stage, we already discussed that we need to flush the specimen with the CO2 and with H2O water, and then we need to check the saturation of the sample. We apply a small cell pressure. A gauge is given to measure the cell pressure, for example, 100 kilopascal or 200 kilopascal or 300 kilopascal, and then we apply the back pressure as well. And if the sample is not already saturated, we can saturate it using the incremental increase of the cell pressure and the back pressure. So we need to saturate this specimen using the back pressure. Here it's given. You can measure the readings, for example, of the back pressure, this dial gauge, cell pressure, this dial gauge, and in the figure as well, that how much is the cell pressure and back pressure. Usually people keep that distance or this difference 5 to 10 kilopascal, and we discussed with Waliullah in our previous class as well, but we can come back to this discussion because you have gained some knowledge and understanding from the assignment as well. So if you need further help from my side, so I'm available. At the end of this class, we will have some discussion on it. Then we measure the pore water pressure using the pore pressure parameter B, and which is also part of the assignment number 1. So we will also discuss that at the end of this lecture as well. But for the time being, B is change in the pore water pressure with the confining pressure, change in the confining pressure. Then we increase the consolidation or the confining pressure. So this confining pressure will be increased once we check the back pressure and the increase in the pore water pressure. And if the B value is, for example, greater than 0.95, if it's greater than 0.95, so we are good, the sample is saturated, and we can move on with the consolidation stage. And in consolidation stage, the back pressure, or in Geotech 2 undergrad, we call that as static pore water pressure as well, because back pressure and pore water pressure would be same. So we will get the 150 kilopascal of the back pressure. So we can call that as the static pore water pressure, and the cell pressure, if you increase it till 250 kilopascal, so the effective confining pressure would be 100 kilopascal, because we already know that it's sigma prime is equal to sigma minus V minus U, and 250 minus 150 is equal to 100 kilopascal. Now we will measure the volume and pressure, pore water pressure as well. So the volumetric change can also be measured, and also the pore water pressure can also be measured using the pore water pressure transducer. Obviously, it's a consolidated drained test, so the pore water pressure reading would be almost close to 0. The excess pore water pressure reading would be 0. Although the static pore water pressure is there, which is 150 kilopascal. 150 kilopascal, okay? Now at the same time, gradually the excess pore water pressure reduces to 0. As we mentioned earlier on, consolidation is complete. So we need to notice the pressure and volumetric change. So when we reach till this point, that we see that almost the pressure versus volume curve has been leveled off, then we will move towards the shearing stage. Now we will start with the shearing of the specimen. There is an equation that how we can shear the specimen, or how we can estimate the shearing strain rate, and we will discuss after this procedure that. But for the time being, the valve is open here. You can clearly see that the valve is open during the shearing stage, and now the piston can move up and the LVDTs are here, the load cells are here to measure the displacement and the loads respectively. We can set the strain rate and we can shear the specimen very slowly so that the pore water pressure won't be generated. We can draw the load settlement, load displacement curves, sigma D and epsilon A. And we can determine the shear strength parameter. So that was one test which we performed for sigma 3 equal to 200 kilopascal. Now we can repeat the same process for 300 kilopascal, and we can repeat the same process for 400 kilopascal. So if you remember in your term project, your sigma 3 for initial case would be 50 kilopascal, and for second case it would be 100 kilopascal, and for the third one it would be 150 kilopascal. So you are going to get 3 more circles, and then you are going to find out the C and phi prime in case of the consolidated drained test, and C and phi prime are the total strength parameters in case of the consolidated undrained test. And that's how you find out the friction, effective friction angle and the effective cohesion. An example is given here that sigma 3 of 200, 300 and 400 confining pressure kilopascals were applied, and sigma 3, sigma 1, which is the sigma 3 plus sigma D. Please kindly find and give me the values of sigma D for case 1 and case 2, sigma D1, sorry, sigma D1, sigma D2, and sigma D3 for each cases. What would be sigma 1, sigma D2, and sigma D3?
Sigma D1 370 सर.
Okay, 370 kilopascal.
575.
Okay.
762.
Okay, now we got the sigma D as well, which is the deviator stress. And if we draw the mole circle, we can find out the C prime and phi prime of 29 degrees. Very much, pretty much very simple example. Now in consolidated undrained test, the basic concept is same, but in shearing stage it would be different. Okay, delta sigma 1 or delta sigma 3 is equal to delta sigma 1 prime is equal to delta sigma 3 prime. Basically we apply sigma 3 of the desired value, for example 50, 100 or 150 kilopascal. Now delta U is 0 because consolidation is in drained condition, and if we see here, the delta Q divided by delta P will be equal to 0 because we are not shearing the specimen. So that's why this equation is valid. Now in shearing phase, delta sigma 1 is greater than 0 because sigma D would be applied, and the change in the confining pressure is equal to 0. So that makes sense as well. And we already know that if you want to find out the effective stresses or the change in the effective stresses, so we can use sigma prime is equal to sigma 1 minus U, or in terms of delta are the changes as well. Now in the shearing phase, the pore water pressure will increase or it will decrease. Okay. Similarly, if delta P is equal to delta sigma 1 divided by 3, or delta Q divided by delta P, it will be equal to 3 if we want to perform the effective stress analysis. Now, if you want to, sorry, the total stress analysis, total stress path. Now, in case of the effective stress analysis or the effective stress path, then the delta Q over P prime relation would be different. So in case of the total stress path or total stress analysis, we are going to use this stress path. So regarding stress path, we will have a discussion in a separate lecture or lectures. But for the time being, this would be for the total stress path, and this would be for the effective stress path, because we are subtracting the pore water pressure in info. For the volumetric strains, as we already know that there would be axial strains and there would be radial strains, but the undrained condition is achieved only and only when it is a constant volume test. Now, in the constant volume, we already discussed that the axial strains can occur, and that can be accommodated by the radial strains epsilon 3, okay? But the volumetric strain would be equal to 0, which means that it is a constant volume test. Similarly, if you want to find out the radial strains, the shear strains, we can find out using these equations, which will be used in solving the examples, numericals, and problems. Again, the elastic moduli for undrained condition can also be found out from the stress strain curves. The schematic that in the consolidation stage, we will apply sigma 3, and the pore water pressure would be equal to 0 because it's consolidation stage, and that is drained. Now, in case of the shearing stage, we are applying delta sigma 3, which is equal to 0, because we will apply sigma 3 and then we are going to shear the specimen, and that is the addition to the delta sigma 3, and we will apply the deviator stress. But the only thing here which we need to note down is that the valve will be closed when this sample is sheared with a certain strain rate. So with a certain strain rate, when we are shearing it, then this valve should be closed, and this will create the undrained condition. Here is an important concept which is discussed. In consolidation stage, no increase in the Q or the deviator stress, and definitely there will be increase in the mean effective stress. So if we want to draw the total stress path, this will look like this, and we know that the total stress path, this is the relationship, which is a very important relationship. Please kindly note down that relationship. Now, if we want to find out the effective stress path, now at each and every point, this would be the subtraction of the pore water pressure as we are moving along the stress strain graph like this. For example, this is the sigma T, I would call that, or Q in terms of here, and this is the epsilon A. So this is the beauty of the advanced soil mechanics here, that as we can see that at each and particular point we are relating the pore water pressure info, the stress strain behavior as well, and the stress path behavior as well. So here we are having stress strain behavior, and here we are having the stress path behavior. And we can also, for example, if it's a compressive or loose sand, so it's positive pore water pressure. So the effective stress path and the total stress path for the time being can also be drawn using the CU tests. If you want to find out the undrained shear strength of the soil, so you can simply multiply, subtract the sigma 3 from sigma 1 at failure and take divided by 2, and you will obtain the undrained shear strength of that soil. If you want to apply sigma 3 on the heavily over-consolidated clay, you will obtain the stress strain behavior, something like this, and you can clearly see the initial compression and then the dilative behavior in over-consolidated clays. Similarly, if you want to apply the sigma 3 and you consolidate the specimen of the normally consolidated clay, so you will see the stress strain behavior or the pore water pressure behavior, something like this, because it will give us the positive pore water pressure. We can draw more circles in terms of the effective stresses and the total stresses, and then we can get the required shear strength parameters related to the peak strength or the critical state strength. Then the process of consolidated drained test, for example, this is the sample preparation. So no increase in the pore water pressure during the sample preparation, and then when you apply sigma 3, so total stress would be transferred to the pore water, and then when we consolidate the specimen in the drain condition, the pore water pressure will dissipate, and after that, if it's a loose sand, then it will increase, the pore water pressure will increase, and if for the dense sand, it will be in this condition. So if you want to draw the pore water pressure versus time behavior, so that's how the pore water pressure variation can be seen in consolidation and shearing stages. Now the undrained failure envelope can be drawn and the drained failure envelope can be drawn. This is the drained failure envelope, and this will be undrained failure envelope, and that's how we can obtain the shear strength parameters. And now for dense sands, this Phi are the total, the friction angle which is obtained from the total stress analysis would be greater than the phi prime. Now delta U is positive for loose sands due to the contraction of those soil particles, which we discussed in our previous lectures as well. And for delta U is negative, and that is due to the OCR, the higher relative density cementation, or even the fiber addition can also densify the soil, so ultimately leading to the dilative behavior of soils, okay, of sands or cohesionless soils. Now, if you want to solve a simple problem or example, so we can solve that, but we will come to these problems later on. Let's solve the normally consolidated behavior and the over consolidated behavior and the pre-consolidation pressure information for these type of soils were discussed in previous lecture as well. The consolidated undrained test, we can find out C and C prime and Phi prime, how we perform this test. Again, we need porous stones, the drainage lines. We consolidate the specimen. The valve is closed, so it was open in drained condition, consolidated drained condition, it was open, and consolidated undrained condition, this valve is closed. Pore water pressures are measured. So the shearing stage will last for a couple of hours, and that is dependent upon the strain rate. Again, sample preparation, saturation. Then you need to check the B value, and then you will consolidate, and then you will shear with certain strain rate. Then these pressures would be applied, cell pressure and back pressure. And this is the pore water pressure measuring device. And this is the back volume. V delta U divided by delta sigma 3. Same procedure which was discussed in unconsolidated, unconfined, and also the consolidated drained test. So therefore we are going a little bit quicker here. The consolidation is complete. You need to see that curve here. Once it's level off, consolidation is complete, and you will go for the shearing stage. And for the undrained test, the wall will be closed there. And after that, you will draw the stress strain behavior. And then the more circles will be drawn, and you will get the required or desired shear strength parameters. A simple example, having the volume of the sample, having the cross-sectional area, and then the loads are transferred, or you will obtain the stresses from the loads and the areas, and you will get the required shear strength parameters. And from the Coulomb's equations, you can find out the shear strength of the soil as well. Now, further examples, simple examples are also given. You can read how you can find the shear strength parameters. Now, why we apply back pressure? I need a short discussion here because you already solved the assignment on sample preparation. So two topics which I need to clarify today is, one thing is related to the back pressure, saturation, and also the another point is the sample preparation, because you are going to start the term project, and even the assignments or quizzes, assignments will be given related to the triaxial test. So you need to basically understand the sample preparation and saturation steps very, very carefully. So why we apply back pressure during the triaxial test? Okay, so the importance of pore water pressure. Where are your assignments? Where are your assignments? Wali, pore pressure parameters.
हाँ सर, ये दो पैरामीटर है, एक कैम्पटन पैरामीटर बी है और दूसरा है।
ओके, तो ए कहाँ पे इस्तेमाल होता है, बी कहाँ पे इस्तेमाल होता है?
बी जो ना हम यूजुअली सिचुरेशन के लिए इस्तेमाल करते थे कि हम सैंपल की सिचुरेशन चेक करें ना कि कितनी % सिचुरेट हो गई है।
ओके।
और दूसरा जो ना वो डिविएट्रिक स्ट्रेस जब अप्लाई करते हैं वह ये पैरामीटर यूज होता है।
आप लैपटॉप पे कनेक्टेड हैं कि सेल फोन पे कनेक्टेड है?
सर अब भी लैपटॉप पे कनेक्ट सर।
तो आप अपनी असाइनमेंट खोल के थोड़ा सा दिखा दें हमें।
जी सर।
प्लीज उसके स्क्रीन जो है ना शेयर करें थोड़ा सा, उसको जो आपने उसको लिखा हुआ है थोड़ा एक्सप्लेन थोड़ा बहुत जो है ना वो ब्रीफली कर लें। बाकी डिटेल में वैसे भी उसकी मैं जा रहा हूँ थोड़ा बहुत, ये जो पोर वाटर प्रेशर पैरामीटर्स हैं। और थैंक यू कि आपने मुझे याद दिलाया ड्यूरिंग द वीक के उसमें जो है ना कैम्पटन की जो 1954 का जो पेपर है वो वहाँ पे उसमें सारी इंफॉर्मेशन मौजूद है। उसमें
सर
एफ जो
वो पेपर मैंने खोला है, वो पेपर अगर डिस्कस करो तो अच्छा होगा सर।
नहीं, असाइनमेंट खोले, असाइनमेंट आपके
ठीक है।
असाइनमेंट में आप खोलेंगे तो मुझे पता चल जाएगा वहाँ से, कोई मसला नहीं।
ठीक है सर।
हाँ, पेपर भी उसके बाद खैर खोल लें, थोड़ा सा जो है ना डिस्कस कर लें, स्टूडेंट के साथ भी डिस्कस करें, शेयर करें उसके साथ।
सही है सर।
अपनी नॉलेज और अंडरस्टैंडिंग की। थैंक यू।
कड़ी दिया खाना का बिगड़े मतलब होगा पता नहीं। स्क्रीन बेल संग शेयर करूंगा।
राइट साइड पे देखें, प्रेजेंट नाउ कुछ ऑप्शन होगा। जब शायद प्लीज हेल्प हिम।
सर हो गया सर,
यस, या नाउ इट्स शेयरिंग। Yes, excellent. Let's start with the pore water pressure first, and then we will go for the sample preparation. And you can zoom in a little bit. You can share, click on the height first. Yeah, and you can click on the height. There is, yeah, height. Perfect. Okay, Wali, please continue.
अच्छा, ये हमारे साथ पोर वाटर प्रेशर जब हम अनड्रेन्ड अनकंसोलिडेटेड अनड्रेन्ड टेस्ट करते हैं कैम्पटन के मुताबिक, उस पिरामिड टेस्ट से हम दोनों ये पैरामीटर मालूम कर सकते हैं। चेंज इन पोर वाटर प्रेशर, इसमें जो ना हमारे साथ एक पैरामीटर है बी और दूसरा ए। बी पैरामीटर सिचुरेशन स्टेज में हम यूज करते हैं यूजुअली, और जो दूसरा पैरामीटर है वो जो हम सैंपल को फेल करते हैं यानी डिविएट्रिक सेल प्रेशर अप्लाई करते हैं ना, उस स्टेज में हम अप्लाई करते हैं। ये इक्वेशन कैसे आ जाते हैं, इसके लिए हम मतलब में यहाँ नीचे कैम्पटन पैरामीटर बी का प्रूफ किया हुआ है, वहां चले जाते हैं। ठीक है, ये जो है ना, अच्छा देखिए ना, ये डायग्राम भी गिवन है। ये जो स्टेज है, ये सिग्मा 3 से जो सेल प्रेशर अप्लाई है ना, उसमें जो है ना हमारे साथ ये जो चेंज इन U3 मतलब डेल्टा U3, ये हमारे साथ सेल प्रेशर के दौरान सिचुरेशन के दौरान जो चेंज आता है पोर वाटर प्रेशर भी, और दूसरा जो डिविएट्रिक स्ट्रेस एप्लीकेशन के दौरान आता है उसको हमने डेल्टा U1 से रिप्रेजेंट किया हुआ है। ठीक है, अब नीचे जाते हैं, इनको नीचे रिलेट करते हैं कि कैसे हमने फाइंड किया हुआ है। प्रूफ ऑफ बी, ये हम सेल प्रेशर जब अप्लाई करते हैं तो सैंपल में जो है ना हमारे साथ इफेक्टिव स्ट्रेसेस आ जाते हैं। तो इफेक्टिव स्ट्रेसेस हमारे साथ बराबर होते हैं चेंज इन इफेक्टिव स्ट्रेस इज इक्वल टू चेंज इन टोटल स्ट्रेस माइनस चेंज इन पोर वाटर प्रेशर। अब इस दौरान चूंकि सैंपल मैंने पार्शियली सैचुरेटेड लिया हुआ है, तो सैंपल में जो एयर वाइड्स होते हैं ना, ठीक है, और दूसरा साइल स्ट्रक्चर होता है। इन दोनों में जो है वो कंप्रेसिबिलिटी आ जाते हैं, वो कोफिशिएंट ऑफ वॉल्यूम कंप्रेसिबिलिटी हम फंक्शन जो टेक्निकल इंजीनियरिंग 2 और 1 में पढ़ते थे कि किसके बराबर होता है, वो चेंज इन वॉल्यूम पर यूनिट चेंज इन स्ट्रेस। इस रिलेशन से हम बी फाइंड करते हैं। अब चूंकि हम अनकंसोलिडेटेड अनड्रेन्ड टेस्ट में वॉल्यूम चेंज जो है ना वो बहुत कम आता है, लेकिन जो है ना वो हमारे साथ एक इक्वेशन के थ्रू हम उसको फाइंड कर रिलेट करते हैं ना, कि ये जो वॉल्यूम चेंज मतलब नहीं आ जाता, लेकिन ये थ्योरेटिकली हमारे साथ एक इक्वेशन है, उसके जरिए हम प्रूव करते हैं। अब चेंज इन वॉल्यूम हमारे साथ जो है ना ये किसके बराबर है वो मालूम करें कि वो कोफिशिएंट ऑफ वॉल्यूम कंप्रेसिबिलिटी ऑफ साइल स्ट्रक्चर, ठीक है, इनटू वॉल्यूम ऑफ ओरिजिनल मतलब साइल के ओरिजिनल जो वॉल्यूम होता है इनटू चेंज इन इफेक्टिव स्ट्रेसेस, ठीक है। और दूसरा जो है ना वो कोफिशिएंट ऑफ वॉल्यूम कंप्रेसिबिलिटी ऑफ द फ्लूइड, क्योंकि एयर वायर्स होते हैं ना, वायर्स भी कंप्रेस तो होते हैं, ठीक है, वायर्स में जो ना एयर भी है और वाटर भी है, तो इसके लिए कोफिशिएंट ऑफ वॉल्यूम कंप्रेसिबिलिटी ऑफ द फ्लूइड लफ्ज इस्तेमाल करते हैं, ठीक है। वो हमारे साथ इस इक्वेशन के बराबर है कि चेंज इन वॉल्यूम ऑफ वायर्स इक्वल टू, और ये जो नेगेटिव सिंबल है हमारे साथ क्योंकि कंप्रेशन आता है, तो कंप्रेशन के लिए हम यूजुअली नेगेटिव लफ्ज इस्तेमाल करते हैं, इसका कोई और मतलब नहीं है। और सी जो हमारे साथ जो है कोफिशिएंट ऑफ वॉल्यूम कंप्रेसिबिलिटी टर्म है, ठीक है। और ये वॉल्यूम ऑफ वाइड्स वी स्मॉल वी जो है ना वो जो सबस्क्रिप्ट में लिखा है वॉल्यूम ऑफ वाइड्स लिखा हुआ है जो वाटर या एयर के जरिए फील है, और चेंज इन पोर वाटर प्रेशर डेल्टा U3 के जरिए मेंशन है। अब ये जो वॉल्यूम ऑफ वाइड्स है ये मालूम करते हैं, ये कैसे मालूम करते हैं, पोरेसिटी से। पोरेसिटी किसके बराबर होते हैं, वॉल्यूम ऑफ वाइड्स डिवाइड बाय टोटल वॉल्यूम। तो वॉल्यूम ऑफ वाइड्स किसके बराबर हो गया, पोरेसिटी टाइम्स वॉल्यूम्स ऑफ वाइड, ठीक है। तो अब ये पोरेसिटी इस इक्वेशन में पुट करें, हमारे साथ वॉल्यूम ऑफ
नीचे आ जाए वली, नीचे आ जाए, नीचे आ जाए,
ठीक है,
सही है, हाँ यहाँ तक सही है, सिंपलीफाई कर, हाँ सिंपलीफाइंग के बाद इक्वेशन के बाद स्टार्ट
ये आ जाता है। तो ये इक्वेशन के साथ मैंने कुछ कंडीशंस लिखे हुए हैं कि हमारे साथ फर्ज करें कि सैचुरेटेड सॉइल हो, जीरो एयर वाइड, मतलब फुली कंप्लीटली फिल्ड विद वाटर, ठीक है। तो ये CV डिवाइड बाय CC टर्म इज अप्रॉक्सीमेटली इक्वल टू 0 आ जाता है, ठीक है। और इसके नीचे रीजन लिखे कि सिंस द कंप्रेसिबिलिटी ऑफ वाटर इज नेग्लिजिबल कंपेयर टू सॉइल स्ट्रक्चर, ठीक है, यानी पूरे थ्रू आउट स्ट्रक्चर में थोड़ी बहुत डिफॉर्मेशन आ जाते हैं, लेकिन वाटर तो इनकम्प्रेसिबल है, ठीक है। तो इसकी वजह से जो ना ये टर्म 0 हो जाता है। जब ये टर्म 0 हो जाता है तो ये सारा 1 के बराबर 1 के बराबर हो गया। तो ये मतलब B इज इक्वल टू डेल्टा U3 इंटू डेल्टा सिग्मा 3 के बराबर हो गया। इसको हम इस रेशियो को हम पोर वाटर प्रेशर पैरामीटर B कहते हैं।
और
ए सर जी जो ना मैंने
चले ए जो है ना शायद एक्सप्लेन कर लेंगे, शायद ए को आप एक्सप्लेन करें प्लीज, इसी असाइनमेंट से, बल्कि अपनी असाइनमेंट से कर लें। आप अपनी असाइनमेंट खोलें, शेयर करें, शाहिद अली खान।
मेरा मैंने तो इस पे काम नहीं किया है, तो इस वजह से मेरा ज्यादा कंसेप्ट हुआ सर।
अच्छा, कोई दूसरा वॉलंटियर है जो कि ए पैरामीटर को एक्सप्लेन करे, जिसने किया हो, वली के अलावा?
स्क्रीन शेयर नहीं कर सकता क्योंकि यहाँ पे इंटरनेट की वजह से लैपटॉप ऑफ कर लिया, मोबाइल से कर रहा हूँ, अगर वैसे हो सके।
नहीं, हमें जनरल स्क्रीन चाहिए कि स्क्रीन थोड़ी सी शेयर हो जाए। वली ने बहुत अच्छा किया, थैंक यू सो मच वली, थैंक यू फॉर योर कंट्रीब्यूशन, थैंक यू फॉर योर एक्सप्लेनेशन। हजरत बिलाल, आप एक्सप्लेन करेंगे? आपके पास लैपटॉप है, स्क्रीन पे अवेलेबल है?
सर मैं भी मोबाइल से कनेक्टेड हूँ, एक्सप्लेन तो कर सकता हूँ, लेकिन वो लैपटॉप से कनेक्टेड वो लेक्चर
नहीं यार, थोड़ा सा जाना वो स्टूडेंट्स के साथ भी शेयर करना है। वो तो मेरे साथ भी मौजूद है, लेकिन थोड़ी सी डिस्कशन हो जाए तो अच्छी बात है। किसी के साथ जो है ना वो मौजूद है तो लैपटॉप के अंदर वो असाइनमेंट मौजूद है तो वो काइंडली शेयर कर लें। ए पैरामीटर को ब्रीफली एक्सप्लेन कर लें। ऑलरेडी जो है ना वो बहुत थोड़ा बहुत मैंने बता दिया था, लेकिन थोड़ा सा डेप्थ में चले जाएं तो अच्छी बात है।
Sir, I have done the handwritten assignment. Should I explain it?
Yes, please kindly share your screen. Yeah, zoom in a bit. Okay. Yes, please start. Your voice is a bit weaker, so if you can speak a bit louder, that would be good for everyone to hear. Thank you.
So we have this Kemptons equation for the pore water pressure. It can be basically be divided. I'll explain its purpose afterwards. I'll just first come to the derivation. This Kemptons equation can be divided into two parts. First, delta U3. This is due to change in pore water pressure, and the other one is delta UD, which is due to change in deviator stress. As Wali has discussed, the delta U3 and the B, its derivation. I would come to this stage, shearing stage. We can calculate B from the consolidation stage in an unconsolidated, undrained test. So we can obtain the value of B from delta U3 and delta sigma 3. Now, once we have obtained this value in the shearing stage, we can use these parameters delta UD, A, B, and delta sigma D to calculate the A parameter.
Okay, thank you very much. Now, what is the practical significance of parameter B and parameter A? Anyone? Thank you, Tehreem. If you know the answer, that's fine. If you don't know, I want anyone else to voluntarily contribute in during the discussion. So if you know, you can add. No worries.
So A parameter is usually symbolizes the changes in pore water pressure under shear loading, and B parameter basically tells us about the degree of saturation of the sample.
Okay, thank you very much. Yeah, that's it. Okay, so my screen is visible, I guess. Is it visible? Please confirm.
Assalamu alaikum, sir.
Walaikum salam.
सर
Is it
ये
visible?
यार स्क्रीन इज विजिबल सर वो लेकिन थोड़ा छोटा है सर.
ओके, थोड़ा छोटा है, चल करके थोड़ा सा मैं उसको देखता हूँ, क्योंकि मुझे तो कह रहे कि रिज्यूम योर प्रेजेंटेशन. रिज्यूम क्यों? हाँ, क्योंकि 2-3 बंदों ने शेयर किया है, तो हो सकता है उसकी वजह से कुछ छोटा हो गया. अभी ठीक हुआ है कि नहीं हुआ?
ठीक हुआ सर. सर एक क्वेश्चन मतलब ये
क्वेश्चन आखिर में. वली थोड़ा सब्र करें, क्वेश्चन आखिर में. मैं क्लास को जो है ना वो थोड़ा सा उसको खत्म करूं, क्वेश्चन आखिर में हम सारी डिस्कशन जो है ना आपके साथ करेंगे. मैं वो अफ्तारी तक जो है ना यहीं पे बैठा हूँ, ठीक है ना?
ठीक है.
सही है, थोड़ा सा वेट करें. इसमें सैंपल प्रिपरेशन में भी क्वेश्चंस हैं, उधर भी जाएंगे. सारे क्वेश्चंस अभी सॉल्व करने हैं मुझसे, ठीक है? क्योंकि आपने टेस्ट रन करना है, तो जितने क्वेश्चन आप पूछ सकते हैं वो मैं इनकरेज करूंगा. लेकिन ये जो लेक्चर्स हैं इसको खत्म करें, इस तरह ना हो कि कुछ स्लाइड्स ले जाए. देखें, यहाँ पे इंपॉर्टेंस of pore water pressure has been discussed. So the importance of pore water pressure here, that for example in the drain case, the change in total stress would cause the change in the pore water pressure, but as the soil is in drained condition, so there won't be any increase in the pore water pressure. Then the change in effective stress would occur because the pore water pressure are dissipating and the volumetric change is occurring. So that's from the practical field point of view, that if the construction process is occurring. Now in the undrained case, for example, initially what would happen, that the stresses would increase, the total stress would increase, and when the total stress would increase, the pore water will take all the load, and after some time then the drained loading would occur, or the stress would be constant, and the dissipation of excess pore water pressure would occur, and the increase in the effective stress would also occur. Now compression initially, initially there is no change in the volume because this is the undrained condition, but then in compression the volumetric changes would occur. So that's the practical significance of the information about the pore water pressure and how you can relate it to the practical field projects. Now the protection is also important for different loading condition in total stress analysis are the effective stress analysis. So these are very important in different loading condition, or even I would say the determining the shear strength parameters as well. So because our topic is on the shear strength parameters. Derivation which Wali explained in detail, and also Tehreem explained detail the parameter A derivation which I find out more interesting and more engaging as well. That was the volumetric strain, or the elastic volumetric strain. So the Kempton paper, which is published in 1954, and that is related to two parameters, as Wali and Karim explained in very good detail. The derivation is there, and I will go to the main equation, which is of interest to us as geotechnical engineer. This equation was derived by the Kempton, and then he named that as B and A parameter. Now, if you see here, delta sigma 1 is equal to delta sigma 3. So this term will become 0. And when this term is 0, delta U will become B and delta sigma 3. And we can say that the B is equal to delta U divided by delta sigma 3. And that is the consolidation stage. Now, when we are talking about the stage 1, now for the stage 2, delta sigma 3 is equal to 0 because sigma 3 is constant. Now, what will happen there? Delta sigma 3 is 0. Now, delta U will become A into delta sigma 1. Now, if you want to find out the A parameter, that would be delta U divided by delta sigma 1. And that delta sigma 1 is the major principal stress. And this is the minor principal stress. Okay. Now, he also assumed that A parameter as for the elastic condition, that A is equal to 1 by 3. And he is mentioning that for some reason. He mentioned that B is equal to 0 for the fully saturated condition, and for the partially saturated condition, he introduced a CF parameter which is related to the compressibility of the pore fluid, but as that pore fluid is not completely saturated, so there will be air pressure and the water pressure, and when the air pressure is greater than the water pressure, then the suction would occur, and that would cause the B value in between 0 and 1. So basically, B parameter represents the soil saturation condition, and B parameter is used in triaxial test for ensuring saturation of triaxial soil specimen. For the perfectly elastic case, A is equal to 1/3, but as we already know that the soil behaves elastoplastically, and these terms will be explained in constitutive modeling, but for the time being, it is not a linear material, it's not an elastic material, so it's an elastoplastic material which has elastic strains and the plastic strains. Therefore, 1/3 is replaced by a parameter A. And for the start of the shearing stage, it would be A parameter, but at the end of the shearing stage, it would be the AF parameter. Where the parameter A at the final or the failure state of that soil. Now, that A parameter is dependent upon the OC, or the normally consolidated clay or over consolidated clay, depending upon the stress history, or even the dense state or the loose state there. Typical values were also presented by Kempton. He noted down and he presented, and he find out that the AF parameter will vary from minus 0.5 till 1.5. And he gave a range of AF parameter for the highly sensitive clays, normally consolidated clays, compacted sandy clay, lightly over consolidated clay. And please kindly note down here that you can see that the negative values of these parameters, AF parameters, could be seen for the compacted clay gravel and heavily over consolidated clay. When I was performing test on the cemented sand, so I noticed that I find out the negative AF parameters for the cemented sands as well. Now the schematic diagram, how this confining stage, the loading stage and the final stage. So you can clearly see the consolidation stage and also the final stage, the AF parameter, and how you can find out the pore water pressure from the consolidation stage and from the shearing stage. So this is the consolidation, this is the shearing stage, and this is the pore water pressure. The way the normally consolidated clay will have a positive pore water pressure and positive A parameters, and here we are having the AF parameter. Okay. For overly consolidated clay, how the pore water pressure initially changes, and then it gives us the negative values due to the suction or the expansion or the dilatancy effect. And the negative pore water pressure parameter AF can be seen here in negative terms, for example, 0.5. Now, a summary is also given to highlight the important points that the pore water pressure prediction is important. Kempton proposed those two parameters. Parameter B can be used for the saturation stage, and the value ranges between 0 to 1, and parameter A changes during the shearing stage of the specimen or even in the field as well. And for the elastic place, A is equal to 1/3. Now there are other apparatuses, for example, simple shear apparatuses, which we discussed a bit in more detail in our introductory class, because the text was mainly focusing on the simple shear. So we discussed on the stacked of rings. If you remember that stacked rings are provided, or the wire reinforced membranes are provided to confine the specimen, and then the sample is applied on the sigma z, and sigma x, or the tau x, is also applied. The shear stresses are applied, and then you will find out the axial strain, the radial strain, or the shear strains. Now, empirical relationships, there are other tests as well. Let me note down that as well, that the ring shear from the GCTS company, that is also a test which will perform for the unlimited period of the stress strain behavior. Ring shear apparatus, there, what as cyclic direct simple shear test, so that's done. Okay. Now we discussed a little bit about the slope stability issues, that how the location of that element beneath the foundation or beneath the tank foundation, how the stresses would occur, how the vertical stresses would occur, and how the horizontal stresses would occur beneath the foundation or beneath the slope or the embankment, and where we need to use which particular test. So for example, the triaxial compression condition, direct shear test condition, or the triaxial extension condition, and how along the different slip plans beneath the foundations, how the different types of test can be used to get the desired or the required shear strength parameters. Similarly, in the piles, which type of test is more likely to give the real field condition shear strength parameters, or if you want to apply the uplift what kind of test we need to perform. So this was all about, you know, giving you an overview, an idea about the type of tests which are lab tests which we can perform to find out the shear strength parameters. Now there is an interesting concept which is discussed here in this figure, and let me tell you that, which will be discussed in the stress path behavior as well. So when we call that CU, it's basically CIU, and when we call that CD, it's basically CID, which is the isotropically consolidated. And now you know very, very well that it's isotropically consolidated undrained compression test in triaxial test. But we can also perform anisotropic, and anisotropic means that you will apply the deviator stress of the Q value, for example 100 kilopascal, and you will also apply a kind of P prime of, for example, 200 kilopascal, and now you are going to shear this specimen. So you bring this specimen till here. Now you will tell that you run the consolidated drained test in compression, or triaxial extension test here, or you know, you can perform triaxial extension test in this way, or even in this way. So these are all the stress paths, or the possible stress paths which this sample can go in either this direction, or even it can go in this direction as well. So these are all the stress paths. So basically this is the isotropic behavior, and here they also called cannot consolidation. Cannot consolidation means that the vertical and horizontal stresses are applied onto this specimen when we are starting the shearing stage. The empirical relations relating to undrained shear strength and normalizing it with the overburden pressure or overburden stress at that particular point, gamma into Z, so you can multiply that the undrained shear strength for the normally consolidated clay. So these are the relationship which can be related to the PI, which is the plasticity index, of soils. Then Ghulam Raza Mizri from University of Illinois, so he also visited Western University in Canada, and I had a very good luck that I met with him and I talked with him for approximately an hour, and I discussed about the drained and undrained condition and the consolidation behavior. So it was almost an hour talking with him. So he is a very, very expert in especially the consolidation behavior and the undrained shear strength of the soil. So in 1975, he performed, he gave this very important equation that you can find out the undrained shear strength of the soil from the overburden pressures, and using this simple equation, which is SU by sigma prime Z naught equal to 0.2, and which gives very accurate results compared to the you know, if you are performing unconfined compression test, or you are performing unconsolidated undrained test. So people find out this equation very helpful. Now there are other equations by Ladd, Jamilkowski, Bolton from UK gave a relationship for the clean quartz sand there, that you know how you can find out, or how you can relate the peak friction angle, critical state friction angle, and the relative density, or the effective stress, or the mean effective stress at failure with each other. Now, what are the different field problems where you will need the consolidated drained test or undrained test? So if first time slope failure is occurring, so it's better to perform consolidated undrained test and consolidated drained test, and to perform the effective stress analysis. Now if you want to perform the on the stress analysis on the cut slope, so for example if we are having a problem of cut slope that you know initially it was also failed before, so you need to perform the consolidated undrained triaxial test, and you need to perform the effective stress analysis. For example, for the earthen dams, you need to perform the total stress analysis and the effective stress analysis. And what type test would be better? For example, the UU-CU test and triaxial permeability test should also be performed. For tunnel linings or tunnels, you need to perform total stress analysis and the effective stress analysis, and you need to perform the UU triaxial and CU triaxial test as well. Now, I took a little bit time today to make it a bit more interesting, this lecture. Thank you for waiting today. Possible research areas. We already know that, for the shear strength parameters, when we put those samples into the direct shear test, you apply some vertical load and you apply shear stresses. I hope that, in triaxial tests which we discussed in the previous class and in today's class, something which you find out really interesting and unique from your undergraduate, and that's what we call that advanced soil mechanics. So possible areas of triaxial apparatus can also be identified, and some of the areas which I have seen, on some areas I have worked on, and on some areas my peers or colleagues, they were working in different labs in South Korea or in Singapore or in Western University Canada. So one of the area which I was fascinated by was sample preparation or sample sizes. So you can clearly see that you can keep the ASTM standard says that you can keep the height to diameter ratio equal to 2. So for the 38 millimeter specimen, the stress strain behavior, the consolidated drained behavior and consolidated undrained behavior was studied at various universities there. Now, you can change the pattern, you can change the sizes of the specimen, okay, and then you can compare the, you can clearly see here the enlarged platons with 38 millimeters. So it's one of the research area which you can do, because it's not just like that you've prepared a specimen of like 50 millimeter and 100 millimeter and you get the stress strain behavior, and then you perform 3 times and repeat this test for 3 times, and then you get the shear strength parameters, and those would be the accurate shear strength parameters. Now, so people are doing research on different sample diameters and also different sample heights to find out the shear strength parameters. The information about the temper, how you can prepare specimens using moist tamping. So we will hear from you people at the end of this class that how the sample preparation is being conducted. But that's how I did it when I was at Western University, and people do it using the tamper at Western. So let me see. So these are the split molds there for different specimen. Internal diameter is 38 millimeter, and that's how we applied vacuum, because the vacuum was available through the pipes there, and we will prepare the specimen for different sizes. Schematic, I also worked on the geotac loading frame. So this is the loading frame, and here is the specimen here. This is the load cell, humidity is placed here, and what else? This is the pore pressure pump, this is the cell pressure pump. So this is the pump which there's an actuator kind of goes up and down, and you can clearly see that the actuator is way above compared to the cell pressure pump. So it means this pump is empty. Now if we are going to run a consolidation stage, so this pump is going down here, so it will be filled. That's how we used to perform the triaxial shear test. But also we performed a CPT calibration chamber test in it. So we will perform the CPT calibration chamber test using this apparatus. Now, sample preparation, I won't go into the details, how we do that, because we discussed a little bit in the previous class as well, and you already did the assignment. So how you are going to measure the weights, and then how you are going to tamp the specimen, and then once the specimen is ready in the compacted layers, you will apply, or you will use 2 lubricated latex membranes, because we are tamping this specimen. So you need to use 2 membranes here, because maybe you have damaged this membrane, the previous one. So in order to avoid any leakage issue, And then if you have a leakage issue, then you won't be able to create the effective stress condition. So if you are unable to create the effective stress condition, it means that you won't be able to run the test. So therefore, and then you connect those drainage lines, and the sample is prepared, and the specimen is placed in the cell. Then why we apply CO2, the explanation is given here, that just to remove, you know, those air present inside here. Or Wali, please, not Wali, not Harim, anyone else, any volunteers, I want to read this. Please kindly help me in reading out these two paragraphs. These are very, very important, that a geotechnical engineer who is performing triaxial test should learn. So I don't want to skip these. Let me remove this one. So I need volunteers here to please help me out with the reading. Rifat, can you help me in reading the orange text? Because that is the CO2 application.
Yes, sir. Hello.
Yeah, Rifat, can you hear me?
Yes, sir.
Please start with as complete.
Can you listen me, sir?
Yes.
So it is stating that is complete saturation of the specimen was required to ensure accurate volume change, and pore pressure measurement. Carbon dioxide was first percolated through all specimen under. Sorry, actually I'm zooming it, sir. So for the delay, small confining pressure of about 5 kPa for about 30 minutes. Compared to air, CO2 is more soluble in water, forming carbonic acid, which reduces the time and pressure required to adequately saturate the specimen. This is uh, 1978. Subsequently, the top and bottom specimen to ensure minimal disturbance to the specimen or dislodging the soil. The pore pressure was monitored carefully during CO2 percolation and flushing with water to ensure that no pore pressure built up inside the specimen, and the effective stress on the specimen was never lost during saturation. Coming to the second paragraph, the saturation procedure was continuing with a bake pressure saturation.
Thank you. Thank you.
Welcome.
Thank you very much.
Welcome.
So first of all, thank you, Rifat. First of all, CO2 is percolated through the triaxial specimen, and the reason is given that, you know, they want to remove the air within those pores, and they want the CO2 to be there, because their CO2 can easily be replaced or removed from the specimen using the flushing of water. Then you need to flush the specimen with a very, very slow rate of the water, for example 1 milliliter per minute, to ensure minimal disturbance to the specimen or dislodging the soil as well. Then saturation can be done using the back pressure, and you can apply 150 kilopascal or 200 kilopascal, and then you go for the shearing stage. Now you go to shearing stage, but you need to determine the strain rate of the shearing as well. And those strain rates are dependent upon the T50 or the T90, which means 50% or 90% degrees of consolidation, and that can be obtained from the consolidation curve. Okay. Now CV and K can also be obtained. Now there is also an interesting area. For example, membrane penetration or the membrane correction should also be applied, because for higher stresses, sometimes these particles, you can clearly see the membrane will become like this at very high pressures, at very high confining pressures. Information is given there. Now, sometimes some people have also researched on the, let's suppose this is the platen here, and let me see if this is the top cap here. So if you lubricate these portions, and then prepare the specimen, and when you are shearing it, so people performed, or various researchers performed the specimen on the lubricated using silicone grease or the oil, and you can also apply. You don't need to apply, or you don't need to lubricate those top and bottom caps there, or pedestals. So they also did research that there are few slight differences which you can observe, and those little bit differences, but that's from the research point of view. So you can clearly see there is not much difference in terms of the practical point of view, but in terms of the research point of view, people are searching different ways that, to remove the errors which are present in the triaxial apparatus. How the sample would fail without the lubrication. So you can see kind of bulging type of behavior in case of the uh, without lubrication, and you can see a bit stiffer kind of response is present with lubrication, removing the friction between those end platens, or removing the different kind of frictional losses. Anyways, these are the areas which you can explore. In my mind, these are coming up to my mind, so you can explore different areas that of research from the internet and from reading various research papers. You can find out the with various confining pressures, with various relative densities, you can get various SU critical, or the undrained shear strength at critical state, or the corrected critical undrained shear strength at the critical state. So you can see, if you apply the corrections, or even the area corrections, you can see the differences in the shear strength of the soil, and you can relate with the percentages as well. So with the different specimen diameter, you can perform research on various effective stresses, and you can play with the various relative density with the corrections as well, and coming up with the percentage of the error. That is significant development in the research related to the triaxial apparatus. Now, stress strain behavior with and without correction can also be plotted. Summary of the applied corrections and the error, the average improvement, or the correction reference. Rho, Zhang, and Garga ASTM standards are proposing few corrections as well. Baldi and Nova, Sarsby et al. So, for example, the bedding error, or the volume changing error, membrane resistance error, area correction error, enlarged and lubricated platens error. So these are all the specimen preparation errors which we can also investigate during our triaxial testing. Tested behavior in undrained condition, and pore water pressure behavior for each and every specimen. You can clearly see the diameter of the specimen and the relative density of the specimen, how the pore water pressure response is changing. And you can clearly see here that the stress strain behavior for the case of, this is the 70 millimeter diameter. Here we are having the 50 millimeter diameter, and here we are having the 38 millimeter diameter. So we are talking about a very loose sand, and we can clearly see that the stress strain behavior for 38 millimeter is greater than the 50 millimeter diameter, and then the 70 millimeter diameter. It means that the samples having the smallest diameter, or the small diameter samples, giving us the greatest strength. of the soil, and that is because of the shear bands which are occurring in these soils, and the reasons and are discussed below. For undrained behavior and for the drained behavior, any volunteer need your help, please, to read out this paragraph. Volunteer, please.
The observed increase in stiffness and shear resistance will decrease. With decreased specimen size could be attributed to shearing along a larger number of shear bands formed in larger specimen and the difference in the available space or freedom from particle rearrangement in the specimen of different size.
Like the shear band formation will also play a vital role in the shear strength of the soil, and the volumetric strain behavior for various specimen diameters, for example, the 38 millimeter, 50 millimeter, and 70 millimeter diameter can be seen with the various relative densities. Now, the mobilized friction angle can also be plotted with the axial strain for various specimen sizes in drained conditions or loose sands, or you can plot the undrained shear strength or SU yield at the yield strength, and the critical straight strength can also be plotted. Now, for example, if we want to perform the compression test, this is the compression behavior, and this is the extension behavior. So we can also perform the compression and extension behavior at P prime is equal to 100 kilopascal, and we can plot the volumetric strain and the axial strain behavior as well. These tests can be performed with various additives, for example, the fibers, cements, and silt content. These are the additives which are used for shallow mixing and deep mixing techniques in Korea, Japan, and China, Malaysia, Singapore. These countries, they are more mainly focusing on the soil improvement techniques. So these kind of projects are very, very important for these countries. So they perform compression and the extension behavior, and you can clearly see the behavior in extension is almost the same for various fibers and cement contents in there. Mixing of fibers, how we can do that is also possible. These are the tests which I performed at Western University, and those are the tests with different confining pressures. For example, 50, 100, 200, 400 kilopascal, and these are the compressive behavior. And here we can see in extension that how we can perform these compressive and extension tests in pure sands and in different fibers and cements, and how we can draw the stress ratios like the Q by P prime ratios, how they are affecting. This is not part of the course there, so the lecture is almost done. So I'm just showing that what we can do with these wonderful apparatus, but if we know how to use it. So the volumetric strain response, the compression and the extension and the dilative behavior was plotted with different confining pressures, different in the pure sand condition, in the fiber cemented sand conditions. That's how the saturation was done. How we can find out the dilatancy angles. So how we can find out the dilatancy for each and every for pure sands, for fiber reinforced sands, for fiber reinforced cemented sands at varying confining pressures. So the latency angles were found out, and it was listed how the state parameter, and that what we will discuss in the constitutive model, that what is state parameters. So peak latency angle, how it changes with the addition of cement and fibers, strength envelopes, how we can find out the phi and C intercept from those. These are the peak friction angles and the cohesion intercepts. These are the uh, phi and C, and I would call that as phi prime at the critical state friction angles from the consolidated drain test in compression and extension. So you can see these are the extension test results that what we find out, and the peak cohesion, the data from Kyuka University, that was the university, the partner collaborative university, the project with which I was working. So these graphs shows the effect of these additives on the pure sand behavior. In the triaxial compression, or the slope of the critical state line, how it changes. These will be discussed in the constitutive modeling development as well, and the parameters which are required. Peak friction angle changes with the state parameter in compression test, and in the extension test, how it changes, and the conclusion was given. Similarly, for the undrained behavior, we can clearly see that how the stress strain behavior is changing, how the stress strain behavior is changing with the addition of fibers. This is the literature review which I conducted, and then the pore water pressure response, how the pore water pressure response is changing with positive or negative, compressive or the dilative behavior, why we are getting it, and how the stress path behavior is changing, and how the stress path can be plotted, and then how to find out the critical state line or the mobilized shear strength parameters phi prime with the shear strain. So these are all the possible research areas which could be conducted using the triaxial apparatus. Okay. Here you can clearly see the definition of the P prime or the mean effective stress in my research paper as well, with the different confining pressures. You can do that with the densities. Testing information is given that whether the test was performed in compression condition or the extension condition, what was the silt percentage, what was the fiber percentage, cement percentage, and the mean effective stress information was given in this testing program table here as well. As I mentioned earlier on, isotropically consolidated, so that CIU in itself says that is isotropically consolidated undrained triaxial compression and extension test. Again, with the various confining pressures, compression and extension tests were performed, and the same failure envelopes, peak latency angles, friction angles, stress paths, those were plotted for in this research paper. But that is focusing on the undrained behavior, and previously we were focusing on the drained behavior. Useful links to the videos are also given, and you can watch this video. I will share this lecture today. Now we are going to see a few videos related to the shear testing, and then we will conclude with our lecture, and we'll go for the discussion of the assignment, sample preparation, and the question and answer session. So hopefully this will answer your few questions, but still if the questions remains, then I will be here to answer this question. So first of all, starting with the specimen preparation, I will make it, quick if it's clear. Please confirm that you can hear the voice or not of this person.
सर ये वीडियो हम खुद देखेंगे, अगर कोई क्वेश्चन वगैरह तो आपसे इंशाल्लाह नेक्स्ट क्लास में करेंगे सर। आपका भी रोजा है सर?
कोई मसला नहीं है। अच्छा, स्पेसिफिक प्रिपरेशन जैना उसमें चले, ये वकार बात कर रहे हैं?
जी सर, मैं बात कर रहा हूँ।
अच्छा वकार, आप थोड़ा सा सैम्पल प्रिपरेशन एक्सप्लेन करें, आप अपनी असाइनमेंट खोलें या जो है ना इस तरह करें कि जो आपने सैम्पल प्रिपरेशन लिखा हुआ है ना उसमें कौन कौन से सैम्पल प्रिपरेशन के मेथड्स हैं वो इस्तेमाल हुए।
सर मैं मोबाइल से हूँ लेकिन
चले वो
ओपन
मेथड्स बता देना, आपने असाइनमेंट तो
ओके सर।
सबमिट किया, चले मैं जो है ना
जी
उसको
सर।
देखता हूँ, यहाँ पे मैं खोलता हूँ,
ओके
मैं
सर।
यहाँ पे चले इस तरह करता हूँ कि जो क्लासरूम में उधर चला जाता हूँ, क्लासरूम में यहाँ पे मीटिंग पे मैं अपनी यहाँ पे यू आर प्रेजेंटिंग, मैं प्रेजेंटेशन को स्टॉप करता हूँ और आपकी प्रेजेंटेशन आपकी जो असाइनमेंट है वो ये मैं खोलता हूँ सबक कर। यहाँ पे हम कहते हैं कह रहे हैं कि ये आसान है, तो चाहता हूँ कि ये जो एरिया है ये आपसे यहाँ पे मिस ना हो जाए, क्योंकि अगर ये आपसे मिस हो गया सैंपल प्रिपरेशन जो आपके पास है, सैचुरेशन है, तो आपको बहुत सारे इशू का सामना करना पड़ेगा। सब्र करें। आपकी 8 पेजेस की असाइनमेंट है और उसमें आपने स्टार्ट किया है कि ट्रायक्सियल टेस्ट से सैंपल प्रिपरेशन से आप स्टार्ट कर लें, चलें बता दें प्लीज।
ओके सर। सर सैंपल प्रिपरेशन के लिए आपने जो हमें 3 मेथड्स बताए थे सर, पहला मेथड था मॉइस्ट टैंपिंग मेथड, दूसरा है एयर फ्लुएशन मेथड एंड थर्ड वन इज वाटर फ्लुएशन। In the first method, sample tamping method. Sir, these are sample tamping method, air pollution, AP method, and WP method are the mostly used laboratory methods. सर इसमें हम
ओके
इस तरह करते हैं कि हम नॉन कोहेसिव सॉइल्स पहले मैं एयर पोल्यूशन मेथड्स एपी से स्टार्ट करता हूँ सर। इसमें सर हम इस तरह करते हैं कि नॉन कोहेसिव सॉइल लेते हैं, फॉर एग्जांपल सॉइल सर। इसका बेसिक जो प्रोसीजर है उसमें हम ग्रेविटी पार्टिकल डिपोजिशंस इन एयर वो करते हैं सर। preferential fabric which mines natural alluvial deposit but fail when used with fine grain sand that cause segregation sir. सेकंड मेथड जो है उसको हम वाटर फ्लुएशन डब्ल्यूपी मेथड कहते हैं। इसमें भी सर हम इस तरह करते हैं कि ग्रेटर होमोजेनिटी डेट आल्सो कंड्यूस टू सेग्रीगेशन फॉर फाइन ग्रेन सैंड्स, ये सर हम चेक करते हैं। तीसरा है जो वो है मॉइस्ट टैंपिंग मेथड, वो हम नॉन कोहेसिव सॉइल उसमें हम सैंडी सिल्टी क्ले एंड मिक्सचर ऑफ सैंड वो भी ले सकते हैं सर। इसमें हम इस तरह करते हैं डिपोजिशन ऑफ मॉइस्ट लेयर्स व्हिच इज कंपैक्टेड आफ्टर डिफरेंट डिपोजिशंस। इसमें हम इस तरह करते हैं लार्ज रेंज ऑफ स्पेसिमेन डेंसिटीज प्रोड्यूस नॉन होमोजेनिटीज स्पेसिमेंस एंड that doesn't simulate fabric and alluvial deposit सर वो हम
ओके गुड।
सर। ओके सर।
Yes, it's done. I'm looking at your table. In fact, you know, I liked your assignment, so I shared the share it on the screen so that the people can see here.
ओके सर।
Celerity position and air pelviation, and the table which you have given is very interesting. That you know for which type of materials we should use which type of method. Basically, air pelviation and moist tamping is mostly used for cohesionless soils, and that's what we used, and that's what you will use in your term projects and assignments as well. And then you came up with the Skimpton parameters, and you gave us the screenshot of that paper, I guess, or maybe from some book there, which states there. You need to write by yourself, because if you just take a snap there, uh, you know, it won't help your understanding, I guess.
सर ये मैं लेटेक्स पे कर रहा था इसमें इक्वेशन को, तो वो सर इस तरह पिक्चर आ गए डायरेक्ट सर इसलिए।
राहत से भी कर सकते हैं, so I will
ओके सर।
no problem. So you know, if you want to write by hand, that is also good, that you can
ओके
write.
सर।
This Skimpton paper, I guess, you know, you are referring to is exactly, yeah, these are the figures from that paper, I guess, or maybe the book somewhere, I don't know, but these are the same things which I have read somewhere during my PhD thesis as well. Okay, thank you very much, Wakar. Okay, the links are given. now
Welcome,
you
sir.
can go, as Wakar is saying, that we can, sir, go through these videos and we can watch. And if you have any question, you will come up and ask, as Wali is going to ask today regarding sample preparation. So my recommendation would be related to the sample preparation. Go for the moist tamping for 60% relative density. You can go for dry rodding. Sometimes air palpation can be added with the dry rodding, so you can use the tamper to achieve the relative density which you want to desire. Because as you see, the research paper would be related to relative density, and then you would be confused that now with which data I should compare my results. Then your results would become useless, or even you can say that you would be alone because you don't have that relative density term there for clean sands. Sometimes the people do research on the salt content as well, so you change the salt content in there, and you see the effect of salt content with different confining pressures, with different relative density, and even the relative density is changing with different confining pressures as well, sorry, with the change in the salt content there. So the minimum and maximum relative density will change, and we will go for the skeletal granular void ratio or skeletal void ratios. Those concepts would be discussed, but that is for the time being beyond the scope of our work. So we can go for the research if someone is interested in doing research related to triaxial tests. So I have few ideas. I worked in South Korea on it. I worked in Singapore, and also worked during my stay in Canada. So if someone wants to do research related to the triaxial test, we can definitely sit there. I have my own data as well, so you can compare with my data, and that data was done collected on the Toyota sand. And as I mentioned earlier on, so that was collaborative project between Fukuoka University. So we can compare the cohesionless soil data which is present here with Wali. So you can collect that data and you can compare with my data as well, and because the consolidation behavior or the grain size distribution behavior would be different, and that would be good way to start with starting the research paper as well. So thank you so much for listening very patiently. I wanted to talk a little bit more. I don't know why my throat is not helping to explain it a little bit more. So I wanted to take it till 6 p.m., but unfortunately I can't. Anyways, now the lecture is done. Wali, we will take that lecture till 6 p.m. by your questions and answer session. Okay, let's try. Wali, please, where are you?
सर वो आपने लेक्चर में एक डायग्राम शो किया था, ये वॉल्यूमेट्रिक स्ट्रेन वर्सेस स्ट्रेन, एक्सियल स्ट्रेन और डिविएट्रिक स्ट्रेस वर्सेस एक्सियल स्ट्रेन का। सर वो काइंडली अगर आप शेयर करें तो।
स्क्रीन शेयर कर लें प्लीज, आप स्क्रीन शेयर कर लें, डायरेक्टली मुझसे जल्दी चले जाएंगे।
नहीं सर, वो आपके लेक्चर में था सर।
इस लेक्चर में? अच्छा, इस लेक्चर में तो फिर मेरे पास होगा। वॉल्यूमेट्रिक स्ट्रेन कहाँ पे है? अब ये ऊपर कंसोलिडेटेड ड्रेन में ही होगा, क्योंकि ड्रेन में हमारे पास वो मौजूद है।
इससे आगे कतल चढ़ाई ₹25,000 का ये 50 घंटे की जी।
नहीं भाई, दलता बड़ा खूब नहीं हुआ नहीं
सर जी। दा दे बिल्कुल दे सर जी।
हाँ,
वो सर थोड़ा जुनाब भी गायब हो गया ना।
सबर करें थोड़ा सा यार। ये वाला
नहीं ये भी जो आया था सर, वो जिसमें वॉल्यूमेट्रिक स्ट्रेन आए थे ना, ग्राफ था सर जी।
अच्छा, सबर करें।
वो नीचे था आई थिंक सो। हाँ सर ये
अच्छा
सर, ये ग्राफ जो है ना, ये लूज सैंड और डेंस सैंड के लिए मेंशन जो है ना सर।
हाँ
सर ये डेंस सैंड में जो है ना, वो वॉल्यूमेट्रिक जो स्ट्रेन आ रहा है ना, वो कंटिन्यूस मतलब डिक्रीज, मतलब कंप्रेशन आ जाती है, मतलब वॉल्यूम डिक्रीज हो जाता है। लेकिन यार हमारे साथ जो ना सैंड की सिचुएशन में ये होता है कि वॉल्यूमेट्रिक स्ट्रेन जीरो हो जाता है, मतलब क्रिटिकल स्टेज पे एक खास स्ट्रेन के बाद। लेकिन यहाँ ये
गुड
बिहेवियर शो नहीं हो रहा है डेंस सैंड में सर।
गुड पॉइंट वली, एक्सीलेंट पॉइंट. Yes, that is an issue, and for that you need to reach to the critical state, and that is the limitations, for the triaxial test which you are going for. Where is my pen here? So actually, this phenomena occurs in very dense sands. Okay, that you won't see the change in volume equal to 0, and if the change in volume is not equal to 0, that concept is related to the stress strain behavior, that the stress strain behavior will also leveled off. Sorry, this. Okay, so the change in delta Q, I would call that as 0 as well, and the change in volume is equal to 0 as well. And when you clip these three things, delta P is also equal to 0, and that is from the stress path point of view. So this would lead to, these all definition would lead to the critical state. Very good question. Okay, excellent question. So this is the limitation of the triaxial test, that you won't be able to reach. I tried this in my PhD thesis as well, that we were able to reach to like 30% axial strain. Now Wally is talking about, the clean sand, that we are unable to reach to that critical state. So I tried even 35% axial strain, and that was the maximum capacity of the axial strain which I can reach in the GDS apparatus. Okay, the GDS apparatus. Now the better thing to do is that you go for the maximum possible strain in your apparatus, and see that what is the volumetric strain which you are getting, and what is the stress strain behavior you are getting. One way is to assume that this is the critical, or you can call that as the assumed critical state. Now the reason I mentioned that apparatus was that if someone raises this question, and that is the ring shear apparatus. So when you are shearing it, so basically till reaching 22% of axial strain, or if I write it down here, it's like approximately 22 millimeter. If the height of specimen is 100 millimeter and the diameter is 50 millimeter, so you have sheared this specimen 25 millimeter of axial strain, but still you are unable to reach to that critical state of that soil. And that's possible because if you are dealing with very dense sand, or even cemented sands, or you are fiber reinforced cemented sands, and this phenomena could occur, and that what I have seen in my thesis as well. If I have this phenomena somewhere, I can show you in the drained behavior. Then you need to assume the critical state at 30% axial strain. Let me show you here as well. Yeah, this is the compression behavior. So you can clearly see that at 15% we are seeing significant differences, and even we saw lots of variation. The delta U was not equal to 0, and I talked with my supervisor, and he told me that this is the most because Fukuoka University did the data till 15%, so I need to reduce my data, the plotting points till 15% axial strain. But I told him that I need to show him up to 30% axial strain, because I performed this till axial strain equal to 30%. So that is possible, and then I made an assumption there that at 30% axial strain I am assuming that this would be the critical state. Now in case of ring shear, so in ring shear apparatus what we usually do, so it's a circular apparatus and this is a hollow one. It's a top view. A top cap is placed on this pedestal, I would call it, and we place the specimen in here with a desired relative density having the minimum and maximum, and then we place the top cap, and the top cap is moving on this soil and it's shearing. So theoretically we can go for unlimited strain level in ring shear to reach to true critical state of the soil. Thank you. There is lots of other explanation as well, but I think so that's enough for your question. Is it clear, Wali?
Yes, sir. Clear हो गया, sir.
Sir, can I leave? Yeah, you want to leave? You can leave. You are marked present. Okay. Please do join the class. It will make this class interesting and it will help other students to learn something from you people as well, and we will share the knowledge. Wali is 370, 575 and 6765.
सर वो मेरा असाइनमेंट सर निकाले, उसमें सर जो ना वो मैं जो आपसे के साथ मेथड डिस्कस कर रहा था ना सैंपल प्रिपरेशन का, उसमें मैंने एक डायग्राम थोड़ा सा डाला हुआ है ना सर, शायद उससे क्लियर हो जाए ना वो शायद।
असाइनमेंट में किस असाइनमेंट में?
मैंने जो असाइनमेंट सबमिट किया उसमें सर रिकमेंडेड मेथड लिखा था सर, मैं अपना स्क्रीन शेयर करूं?
ओ वलिनो सादा साड़ी अथवा मंग माने जिकम दे स्क्रीन शेयर के हां उस दल तक इस्ता सही दे। ओके सा सही है, यहां से मैं खोल लेता हूं, कोई मसला नहीं है।
लास्ट में जो ना मेथड में
Well, this is a very interesting paper for you. Okay, please read this paper. LAD 1974 and 1978, I guess. These are the papers under compaction technique. These are discussed. Water pelviation recommendation.
ये रिकमेंडेशन सर, ये मेरे मतलब
Okay. Okay, this is good. Okay. Nice. We can use the principle of centrifugal force to get the. So, are we going to use the air pelviation here?
नो सर, एनी डिस्टर्ब स्टेट में सर जो है ना हम साइल को यहाँ फील कर सकते हैं इसमें, क्योंकि हम जो है ना वो साइल को रोटेट कर रहे हैं तो साइल पार्टिकल जो है ना उस सेंट्रीफ्यूगल फोर्स हर पार्टिकल पे लगेगा ना।
हाँ,
तो ये जो बकेट है ये मतलब सेंपलर ही कंसीडर करें ना, ये बैक साइड से जो है ना हमारे साथ ये नीचे से बंद है।
Anyways, show me the reference, show me the reference that from where you have taken this concept. I have another concept which I will also discuss it with you, and we have tried that as well, because we can place the plastic tins, kind of like tins there, small plastic tins from aluminum foils where they were made, and we tried with those aluminum foils that how many particles are, how much, what is what mass of that particle or weight of that particle can be placed in different layers. But that was done in the calibration chamber test, not in the triaxial one, but definitely we can work. So these are the areas which we can definitely work on the triaxial apparatus. So thank you very much for taking very good interest in this topic, and thank you. If you have any other question, you can ask. I'm here. Regarding previous lecture, regarding this lecture, so you can ask. Yes, Wakar, you want to leave, you can leave. Okay, anyone who wants to leave from this class? Daniel, welcome to this class. I hope you will find out the recorded lectures there. Sorry for a bit delay, because I was waiting from the postgraduate office to confirm, to officially confirm that you are included in the class. So sorry for the delay, but now you can access the recorded lectures and you can participate as well.
Thank you, sir.
Okay, so if you don't have any question and you have already marked present as well, so thank you very much. You can leave the class if you want. Allah Hafiz.
Allah Hafiz.